My name is Rene, and in this lecture, I will cover mobility forecasting and one framework how to forecast the mobility. So, the purpose for this lecture is to review a mobility forecasting theory and adapt it framework to your project. The outcomes are theory and mobility forecasting framework steps description. So, in other words, you have to describe a forecasting framework every step, and you can include this to your theory part of the project. Topics are mobility modeling. So we use a general 4 steps framework for that. And also we have gravity model to analyze traffic split between schools. I want to remember you that you have 3 schools and you have to split all students between those 3 schools. So, what is non-motorized mobility? We are focusing now more on sustainable transport types, and non-motorized mobility is that kind of type. Demand still stays on comfort and individuality, and it decreases the development of the sustainable transport because commuters will use often their own car, not public transport or bicycle. And what is a framework? So we have to use framework on our project that is forecasting mobility. So that means we have common structure for making things, and it's very important to all participants understand how to make things at the same level. But inside those steps, you always solve problem in different context. We have like context for the non-motorized traffic, we have for motorized traffic, this is the different context, and so on. We have different cities. And mostly we tell what are the steps, very important is the steps order, and generalize what we'll do inside those steps. So there is a like description for every step, what to do inside it. 4 steps model purpose is that it will forecast travel demand in near future. That means you can take into the account of what will change in land use or population in near future, but you not know exactly in the far away future. So this is a visualization of this 4-step framework. The first step is trip generation. The second one is trip distribution. The third one is mode split, and the fourth one is trip assignment. Let's take the first one, and you see we have like supply side and we have attraction side. The supply side has own area, and we want to know how many trips are outgoing from this area. In our projects we have 1 square kilometer for that, the area, and we want to know how many trips are outgoing from there. The second part or step is trip distribution, and here we take that particular area and we now link it with specific school. We want to know how many students go to school 1, how many students will go to the school 2 or school 3. Then we have to forecast the mode split. And what is mean? Means that what mode will commuters take? Will they take a car, or are they going to on foot or bicycle? So there are different modes to take. And the last one is trip assignment. where we connect together the starting point and the end point, and we use also additional to a traffic network. So we want to understand what is the shortest path from start to end point. So the first step, trip generation, mostly they take into account following home-based work trips, home-based shopping trips. So from home to work or from home to shop, also home-based education trip or non-home-based trips. And what we want to predict is the number of trips originating in our destination for a particular traffic analysis soon. And I want to tell it again that for our project, the analysis soon is the area where the students live, that 1 square kilometer. So the first step is trip generation, and here we can see that household with 2 vehicles, and there are living 4 people, maybe assumed to produce 3 work trips per day. So we have understanding when particular area live about people, x number of people, we know how much vehicles are per inhabitant. We could say how many work trips per day they are producing from particular area. So for this step we want to input from statistical findings, and we want to know the area, the bounding area, and output on that step is out trips number per area. So we want to know how many trips those people will produces. The second step is trip distribution, and here we are matching every trip maker, origin and destination to develop a trip matrix table. So this is a table where we are going to exactly tell where inhabitants start their trip and where they are ending it, and also the volume of those trips. So the second step is very important, and we are taking focus on that step on the project. This is mostly used, we are mostly using a gravity model to distribute those trips. There are more than that, there are other models also, but we are not covering them. And gravity model take input from one zone and distribute trips to other zones. In our context, we are taking zones input and distribute trips to really between schools. On that step, the input is how many trips per area we are making, and the output is matching origin and destination area and volume. So we know how many students we have in particular area, and so we know how many trips they are making. This is a OD matrix table. We have origin zones, and we have destination schools, yeah? And we want to match zones with a particular school and how much students will go to from particular zone to particular school. So model split, we want to know what type of model will people choose. Are they choosing bus, taking on foot, the trip, taking the car or bicycle? The input for this step is OD matrix and statistical reports. We see the statistical report afterward, and output how many inhabitants will take named transportation type when we think our project is non-motorized traffic. So it have to be either on foot or bicycle. Traffic assignment is the last step in 4-step mobility forecasting. framework, we want to know what is the minimum path from origin to destination, and we are taking account streets network for that. So like I said, very important part of the project is self-gravity model. This self-gravity model tells us that whatever the object is bigger or near to the starting point, the more it is going to pull something. So in our context, it means when school has more or higher students maximum number, whatever distance is closer to the area where students start their trip, it will pull more students from this area. So self-gravity model formula is over here, but I will explain it a little better by this example. And this is also from another context, so you have to adapt it to your context. But workplaces are the maximum number of working places. The distance is from starting point to the working place, and when we have different working places or different areas, we have to sum all those areas together, and we also have to multiply it by potential people who will start their trip from this area. I will skip this part, but I will explain it a little better over here. So we have zone X, and we want to know how many trips are going to the zone E1 or E2. For that, we are going to use self-gravity model. So we know the trips N are the maximum number of students on that zone, and we have to divide those students between two schools. Whatever the school is nearer or bigger, it will pull more students to there. And more about the modality split. Here we see that this is a little example, and it's based on the statistics. To the work, there are 70% of the inhabitants going by car, and to school about 35% of the total commuters. And you see pedestrians or bicycles, those numbers are very low. Pedestrians, about half of the pedestrians will go to school on foot, so that's a very good number. We have to take those things into account because we want to know how far is okay to make non-motorized traffic network from school. It is not valuable to make it 10 kilometers because their students never make that long trip to school on foot. And we have to take account that those potential people who will start moving, so those are the inhabitants or students on that particular area. But it is all for today. Next, you have to take a task in Moodle. You have to describe all those 4 steps of traffic forecasting framework. And what to do is to talk about it in the context of cookies. Like, what should we do on every step, as I described it in your context as a school and students. You don't have to be very specific when you don't know exactly at the moment, but try to understand what you have to do on every step. Submit a task assignment to Moodle. So that's all. Thank you for your attention and see you next week.